going to do next is I'm going to spend about 15, 20 minutes in this section, then we'll talk about cardiac valves, and that'll be pretty much this section for your exam. So we should be done around 10:15 at the latest, okay? So that way you guys get the rest of the morning down, okay? Or need to do whichever you need to do. The next discussion is on long-term regulation of arterial pressure. And when we go into long-term regulation, we're going to go into this in a lot more detail when we talk about the kidney, because the kidney is really the main mechanism that controls long-term regulation, basically by changing the volume inside in your body. Okay, most people think that it's a regulation of water, and the answer is no. The body doesn't regulate your volume by sensing water levels. It actually senses sodium levels. Okay, so sodium is one of those extremely important components that your body's constantly trying to monitor and basically gauge from that how much volume is in your body. What you're trying to do is you're trying to maintain a steady fluid balance and arterial pressure. If you see an increase in mean arterial pressure, it usually leads to more diuresis, which means that your volume starts to decrease. On the other hand, lowered mean arterial pressure leads to an increase in water expansion and more water retention. Eventually, long-term regulation actually affects the arterial pressure on urinary output rate. Is fairly a constant thing to try to maintain a certain amount of volume. Let's say, for example, most people believe that caffeine is actually a diuretic. And caffeine is actually not a diuretic, okay? Believe it or not. Okay, so if you take a cup of coffee and you drink it, okay, and you check and about half an hour later you urinate, okay, it's the same amount of volume that you basically took in. So that's not a diuretic. A diuretic would make you hypovolemic. Okay, so when you drink 10 cups of water, it'd be the equivalent. You start putting out 10 cups of water in urine. Okay, your body's trying to maintain a constant balance at all times. Okay. Now, what you're looking at is how the mechanism is controlled is, to a certain degree, by the kidney, is by sensing this arterial pressure. Okay? If you're looking at the actual central nervous system, we see a decrease in arterial pressure, is that you see an activation of the hypothalamus, which causes the posterior pituitary to release increasing levels of antidiuretic hormone. Okay, so that hormone is going to go on to help retain more water. Okay, that's the antidiuretic component. In addition to that, the central nervous system is going to cause renal sympathetic nerve activity. Okay, and when that does that, it causes an increase in renin release. Okay, remember the renin-angiotensin system, how we described it? It basically increases a cascade event. Okay, so angiotensinogen is going to be broken into angiotensin 1. Angiotensin 1 is going to be converted by ACE into angiotensin 2 in your lungs. And then angiotensin 2 is then going to cause aldosterone to increase its levels. Okay? And that's really the major mechanism that controls volume in your body. It's not so much antidiuretic hormone, it's really aldosterone. Okay? Because aldosterone is what regulates sodium balance. And when the renin-angiotensin system becomes activated, angiotensin 2 will cause a significant increase in aldosterone release by the adrenal cortex. And that causes an increase in sodium reabsorption in the kidney, and then, as a consequence, will pull more water in with it, and then increases the volume. Okay? Many things increase aldosterone secretion. Not only the renin-angiotensin system, things like adrenocorticotropic hormone, okay, hyponatremia, okay, and hyperkalemia will induce an increase in aldosterone secretion. Okay? Once you see this increase in sympathetic nervous system activity, you see an increase in renal arterial vasoconstriction, and you see also a decrease in arterial pressure leads to a decrease in kidney blood flow. Okay? This leads to a decrease in GFR, which is what we call glomerular filtration rate. You don't have to memorize that just yet. Just know that it's affecting a decrease in perfusion to the kidney. And as a consequence, you're going to get less diuresis taking place. Less filtration, so you're going to get as a consequence, less volume in your urine. Okay? So this is the angiotensin system I talked to you about, going to aldosterone, going to sodium reabsorption, going to water, okay? And then ADH, working also in the kidney to increase water reabsorption, okay? Of the two, which one's more powerful? This one's more powerful than this one, okay? ADH is very critical in our case in the sense of the operating room, okay? But it's the actual aldosterone is much more of a long-term player. ADH tends to be used for like temporizing. Okay, if I put excessive positive pressure airway into your lungs, okay, it increases the release of antidiuretic hormone. Okay, it also leads to an increase in what's called the atrionatritic peptide. It decreases the actual value, which also retains your urine. Okay, that's a different mechanism, but overall the effects is that the aldosterone is more important in the whole thing, into causing more renal sodium reabsorption. Okay. Because you see the decrease in GFR, glomerular filtration rate, you do see an increase in renin release. It's also a stimulant, and this causes a decrease in urine output, okay, as well as reabsorption causes a decrease in urine output. So people that have a decreased mean arterial pressure, you can expect that their urine output should drop. That's exactly what should happen. Okay? If you don't see that, it's something else is wrong, okay, which we'll talk about later on in pathophysiology. All right, so this is pretty much all the cardiac section. I have to do the cardiac valves next, okay, which I'm going to talk about. And it should take about 20 minutes or so, and then we'll be done.